Sure? Yeah, good. All right. Let's try and answer some of your questions first of all. One, do you think a light car is faster than a heavier car? What do you think about that? You do. Why would that? Why would a light car be faster? Yeah? Come on. It doesn't accelerate so fast. Do you think that a longer car will be a heavier or a lighter car? So if a long car is... Well, no. Well, it depends on what it's made of, doesn't it? I mean, it could be made of paper. It could be very, very light. But the longer the car is, of course, the heavier it is going to be. Sorry, you're on the way there. Do you think that a car will be faster or slower? No, I can't understand that one. What materials will be better for a lighter car? What materials? You heard of carbon fiber? Yeah? What is carbon fiber? Titanium? Tell us about titanium. It's a metal, and it's light, and it's very strong. Yeah. It's what? Very expensive. Go on, move on. Do you think thicker wheels will be better or worse than thinner wheels? Now that's a clever one. You've got an answer to that, yeah? Because? Okay, you think thinner wheels will go faster. Well, actually what happens here is that the thinner wheels will enable the car to go faster because basically there is less wind resistance because they're narrower, right? But there's also a problem. If the wheels are made very thin, then in our case, we run on a desert and the car will actually slip down into the desert and that will slow it up. So it's a bit of everything, really. Do you think that there should be a big engine in a small car? Yes, of course there is. Right, but very important is that the car looks good. Now that's very interesting. The car looks good. Well, when we do these cars, we don't design them to look good. We design them to work. Okay, so there's no styling in these cars. It's all about making it work properly. And to make it look good, the only bit we do there is the paint. Okay. Right. Where is my button pusher? Rick? Where's he gone? Rick? Hello, Rich. Rich, can you do the... Right, okay. We're going to move on now and have a look at some things. Right. Okay, can we just move into the first one now? Now, what we're doing here is we're watching thrust SSC break the sound barrier. Now, you don't want the glasses, you don't need the glasses. Okay, can we turn it up, please? We have some sound. Okay, now this is the big thrust SSC car. Okay, and it's driven by Andy Green, and it's on the Black Rock Desert in Nevada. Okay, so Andy's sitting in here in the middle where the, I don't know if you move that thing out of the way. And then we've got the two big jet engines there. It's 100,000 horsepower, right? So it's equivalent of about 160 Formula One cars. Very, very powerful. Why do we need so much power? Well, of course, yes, but why? Why do we need so much power to make it go fast? Because yeah, well, they're linking the two together. Now, what happens is that the resistance, there are two forms of resistance, which is air resistance and the wheel resistance, okay? And basically, these increase very substantially the faster you go, so you need much more power. So if you took your dad's car and you wanted to go twice as fast, you need 8 times as much power. Okay, so Andy's sitting in the cockpit there, he's just waiting. We have our fire engine, which is a Jaguar fire tender, and it's just been there to get the engine started, and now he's racing up to the middle point of the desert. We are on the Black Rock Desert, which is an alkali playa. It's not a salt lake, it's an alkali playa, 100 miles north of Reno in Nevada in the US. So Andy's just got the engine started and he's just checking himself out while we're waiting. Now the jet engines have a thing called an afterburner. An afterburner produces an enormous flame out of each engine. That provides a terrific boost to the engines. And what we do when we start off with this car is we start off very, very gently, very slowly. Almost, you know, you can almost do better on your bicycle. Because if we open the engine's up, and it just suck up the desert, and it doesn't do the engines any good. So we've got to move ahead very, very slowly, and then gradually up the speed. Now another thing too is that you see the car's quite dirty. Alright, he's going to go in a moment. Now the car's quite dirty. My son Jack was responsible for cleaning it. Every time he cleaned it, it took him 16 hours. But when we started going supersonic, the car cleaned itself, so we didn't need Jack. So Andy's just getting himself ready now, and he's off, done. You see he's moving very, very slowly. Very, very slowly away. Remember, he's going to go at Mach 1.02. 1.02 times the speed of sound. When he goes very fast, look out for the shock wave that sits on top of the cockpit there. That's where he's sitting. Okay, do you see it's probably going 60 or 70 miles an hour now. Very, very slow. Okay, now he can start to wind the engines up. He's going to light the afterburners for the moment. Look for the flames, alright? You see a little flame inside initially while we just make sure that everything's stable. Okay, 100 miles an hour. Now he's gone to a min burner, so watch for the flames. Okay. There we are, you can just see them, yeah. Okay, so he's just checking everything's alright. Now we'll open it right up. And we only get full power when we get to about 200 miles an hour. So there we are, that's better, now we're off. And after a bit, it gets a bit too difficult for the camera. So you'll see in a moment, but the camera will come back in a moment. There we are. And now he's drifting away from the centre of the line because there's a funny aerodynamic effect which is causing that. And he's bringing back onto the line again. You see the shock wave building up. Do you see it over the cockpit as the air goes faster than the speed of sound there? There we are. And he's through. He's through the measured mile now, and he's just slowing up now. You can see the car's lovely too. Okay, let's just stop it there. Should we try